Welcome back to Learn as You Explore for the fourth video in the mBot2 tutorial series. In the last video, we learned how to build a block program, upload it, and test it out on the mBot2 robot. In this video, we'll do the same but with a different block program. We are going to explore the ultrasonic sensor in this video. Let's dive right in. The first thing we would do, as always, is to go to the code editor. And a shortcut to do that is to go to ide.mblock.cc. That loads the code editor. Let's give our project a name here so that we can save it. So let's change the untitled to what this is. It's like the ultrasonic sensor demo is what I'll call it. Now let's add our mBot2 robot. All right, so we have the mBot2. Click OK. The goal of our program today is to display the values that the ultrasonic sensor is measuring onto the CyberPi display. But before we do that, let's talk about what an ultrasonic sensor is. In simple terms, an ultrasonic sensor is a sensor that measures distance. So this is what an ultrasonic sensor looks like. I got to this page by just searching for ultrasonic sensor principle and going into the images tab. The way it works is it emits sound from the transmitter. This sound that it emits is at a frequency that is above what humans can hear, and hence it's called ultrasonic. The emitted sound waves travel along a path until it hits an obstacle. In this case, it's this object. The sound waves get reflected by the object and is received by the receiver end of the ultrasonic sensor. And you can imagine that if this object was closer, then the time that it takes for the receiver to receive the signal would be shorter. And as the object moves far away, the ultrasonic waves have a longer distance to go until they hit the object and get reflected and go back to the receiving end. And so, based on the time that it takes for the receiver to receive the waves emitted by the transmitter, the ultrasonic sensor estimates how far this object is. If all of that was a bit too much, all you have to remember for this exercise is that an ultrasonic sensor gives us a measure of distance to the closest obstacle in its path. Let's head back to our code editor and start programming now. As always, we want some trigger or some control to start the program. We'll go to our events block category and we'll choose the when button A is pressed. Last time we used button A, this time we're going to try out button B instead. So when button B is pressed, what do we want to do? I mentioned that the goal of our program today is to display the ultrasonic sensor's measurements onto the CyberPi display. So first, let's look at how we can display something on the CyberPi. To do that, we go to the block category, name, you guessed it, display, and we pick the block that says just print something, right? In this case, it says print make block for the example. We will take that and click and drag it and snap it onto your previous block. So now we have our program, which is going to print the word make block onto the CyberPi display. Print is just another term to mean display. It is commonly used in programming languages, but all you have to know is that print pretty much just means display on the screen. So now, instead of make block, we want to display the value that's measured by the ultrasonic sensor. So let's find a block that gives us the value measured by the ultrasonic sensor. To do that, we can scroll on down to the block categories, and in there we see a separate category that says ultrasonic sensor 2. So let's click on that. And here, the very first block gives us the distance to an object, which is exactly what we want. So let's click that and bring it on here. Now you'll notice that this block does not snap on to the previous block like before. You'll also notice that the shape of this block is somewhat different. It does not have this puzzle piece shape that the other two blocks that we've used have. However, if you look at the shape, it is very similar to this oval make block area of the print block. So what this block is meant to do is to replace whatever you can print in here. As you can see here, as we bring this block closer, the block within print that says make block right now is highlighted in white. So if we let go of this block at this point, you'll see that it snaps on inside the print block. And what we've achieved now is this block program that says when button B is pressed, print whatever the ultrasonics distance to an object is onto the CyberPi display. And this is exactly what we wanted. So let's connect our robot now. We can upload this code and test it out. Let's head on over to connect our robot now. To connect your mBot2 robot to your computer, we'll use the provided USB-C to USB-A cable. This cable comes in the box with the mBot2 robot. The smaller USB-C end connects to your robot, while the slightly larger USB-A end connects to your computer. Let's plug in the USB-C end to the robot. Flip over the robot to its side. When facing the robot, this would be on the left side. You see a port named USB here. Take the USB-C end of the cable and connect it to this port on the robot. Next, we'll plug in the USB-A end to your computer. We can now head back to the editor to continue. Now that we've connected the robot to the computer, we're going to go ahead and upload this code that prints the ultrasonic sensor's readings onto the CyberPi display. Since we have a physical connection, we will go over to Serial, select the USB serial device, and click Connect. Now that the robot is connected, we will upload the code. The code has been uploaded. Let's head on to the robot and test it out. Now that the block program has been uploaded, we can unplug the USB cable on the robot end as a safety measure before we test it out. The square button on the robot is button A and the triangular button is button B. In our code, we instructed that the ultrasonic sensor's distance measurement should be displayed on the CyberPi display when the B button is pressed. Let's press button B to see what distance the ultrasonic sensor reads. The ultrasonic sensor says that the closest object along its path is 207.9 centimeters away. Great! Now that this works, let's try placing an object, say my hand, at a closer distance and see what it measures. Press button B again, and we see something weird. What happened here? It looks like the latest reading is 12.7 centimeters, but it is being combined with the previous reading on the display. This does not look good, so let's fix this by going back to our block program. Let's see how we can fix the problem that we observed where ultrasonic distance sensor measurements were being combined on the CyberPi display. So our code says that whenever button B is pressed, we're going to get the ultrasonic sensor distance and print it on the display. And we see this exact behavior during our test. Whenever button B is pressed, we print the ultrasonic distance measurement on the CyberPi display. And the next time we press button B, we print again without adding a space or a new line, and hence the readings get combined together. This is our problem. One way to fix this would be to add a new line every time we want to display the ultrasonic sensor's distance measurement on the display. To do that, let's head on over to the display block category. And if we look at the blocks that are available, the very first one actually says print something and move to a new line. This is different from the block that we previously used, which was the second one here, which was just to print something on the display. If we use this, we can imagine that we would print the ultrasonic sensor distance measurement and move to a new line. So then the next time we want to print something, we're already on a new line, and every time we print something, it would not be combined with the previous content on the display. So what we want to do here, we want to replace this print block with a print something and move to new line block. So let's disconnect this block, take it away. Now let's go back to the display block category, bring the block that we really want and attach that to the previous block. Take the ultrasonic sensor distance measurement and replace the make block sub block. Now we can get rid of this separate block that isn't connected to anything. And now let's review our program. Our program says when the button B is pressed, we are going to print the ultrasonic sensor distance measurement and move to a new line. This looks great. Now that we have the updated code, let's go ahead and upload this to the robot. Make sure that the robot is connected to your computer and then go to the upload tab here and select serial, select the USB serial device and click connect, and finally upload code. Once the code has been uploaded, we can now go and test on the robot. With the uploaded code, let's retest our program. Let's press button B once to get the first ultrasonic sensor distance measurement. And we see that it says 211.7 centimeters. Now let's do a close-up object test. Press button B again, and now we see that the next distance is displayed on the next line. Let's do a third test, and we see that every new distance measurement that we get by pressing button B is placed on a new line, making it easy to read, and it looks just like we want it to. Congratulations on learning about the ultrasonic sensor. In the coming videos, we'll learn how to apply the ultrasonic sensor to bigger projects like obstacle avoidance. If you found value in this video, please hit the like button and subscribe for more tutorials on the mBot robot. Share with your friends who may be interested to support this channel. Looking for more mBot2 tutorials? Check out these videos from this playlist. Thanks again for joining me today, and I'll see you in the next one.